Welcome to 6.3 Rational Equations and Applications. So, rational equation deals with what we did previously, simplifying with rational expressions. Mainly we're going to be working with fractions. Now, we're going to start off easy where we have two fractions being combined, meaning added together where it equals to 3, with different denominators, and we have numbers as our denominators, while we have x's in our numerator. So, before you can start any kind of solving, and when dealing with fractions, we want to make sure that we can combine these two fractions together. In order to combine these two fractions together, then you always be hearing this key phrase is that they need to have common denominator, meaning that the denominator has to be the same. So let me elaborate on that. It could be, what I mean by the same is that it doesn't have to be exactly the same. It can look the same. So when we progress to more complex examples, you'll see that when I'm talking about common denominator, is mean what do you need to do for these denominators to look the same. So that's what I mean, not just by we need to have exact same denominator, but denominator that looks the same so that we can move on to the next step. So right now we have a denominator of 4 and denominator 6. If you want to get the same, the common denominator would be 12. So what I would do here is, in order to get 12, I would multiply 3 on the first fraction to the numerator and denominator, and then by 2 on the second fraction to the numerator and denominator. So when I multiply, what I'm going to have is in the first fraction would be 3x over 12 plus 2x over 12 equals to 3. Now once these denominators are the same, then you can combine as one fraction. So it will be 3x plus 2x over 12 equals to 3. And then when I simplify that further, it will be 5x over 12 equals to 3. 3x plus 2x, that's 5x. Since we have a fraction and we're trying to solve for x, I'm going to multiply by 12 on both sides. So that way, when you multiply by 12, I won't have a fraction. I'm simply going to have just 5x. So I'm going to write over here, 5x equal to 3 times 12 is 36. And then what I need to do to solve for x is divide by 5. X equals 36 over 5. Alright, so that's all we have to do since we have a denominator and our fraction. This is our final answer. So again, it's pretty simple when you're working with denominators that are numbers. It's going to get a little bit complicated, and I would say a little complicated. Once you understand the process, once you understand the patterns, it's a little bit more work. But that means we're going to be working with variables in the denominator. Alright, in this example, we have x in our denominator. So pertaining to what I said previously, when we were working with variables in the denominator, we're just going to be doing more steps. It's going to look complicated, but again, once you understand the patterns and the process, it's fairly simple. It's just going to be more steps to it. Now, the difference between x and 5x, again, when we're working with fractions and if we were to combine them, adding or subtracting, we need to have the same denominator, or a denominator that looks the same. So the difference between x and 5x is that this one has 5x. So in order to convert or change x into 5x, simply just multiply by 5 to the numerator and denominator. When you do that, your first fraction will be 15 over 5x minus, and our second fraction you just bring it down, 2 over 5x equals to 2. So we can combine this as one fraction because now they have the same denominator. So 15 minus 2 over 5x equals to 2. Then this will be 13 over 5x equals to 2. Since we have 5x in the denominator, what I'm going to do is multiply both sides by 5x. So that way, when I divide, I won't have a fraction anymore. Now, when I multiply both sides by 5x, what I'm going to have is 13 equals 2 times 5x is 10x. And then in order to solve for x, I'm going to divide both sides by 10. So our x will equal to 13 over 10. So again, just having the variable in the denominator looks complicated, but it's not really. And we've already did the same amount of steps compared to the last example, which was just basically, again, same denominator. When combine the fraction, that's 1, and then just solving for our missing variable.